Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the reconciliation fiber tree. In the previous video, we have learned about the render phase. So how the render phase is happening and all those things we have seen it. Now we have stopped it at the place of reconciliation after creating the virtual DOM. So what will happen? So let's try to learn about this fiber tree and all those things. In this video, we will learn about the reconciliation and the fiber tree. So try to learn it, try to understand it very carefully. So it is little bit of confused things to most of the developers. So I will try to explain you as simple as possible. So let's learn it. The reconciliation process result is gonna be an updated fiber tree. So the process which the reconciler will do is the result will be an updated fiber tree. What is this updated fiber tree and all those things? We'll try to learn it. This tree will eventually be used to write to the DOM. So this is the tree which will eventually use it to write to the DOM, not the virtual DOM. So virtual DOM doesn't have anything to do with the DOM updates. So that DOM updates, everything will be done through the fiber tree. So that is also an updated fiber tree. So this is the high level overview of the input and output of the reconciliation. So now what is the process we'll try to. Now we need to understand that what reconciliation is and how it works. So this is the main question what we will be having. Now you may be wondering that why we need to have a virtual DOM, a reconciler and the fiber trees. So these three technical terms we have learned it, right? Virtual DOM we understood. For reconciliation, virtual DOM is nothing but the React element tree only. So whatever the component got executed, it returns the component function returns the React element. So that is that all the component structure and all the things combines the React element tree. Now a reconciliation and those fiber trees. So reconciler means nothing but it will create an fiber tree. So using that virtual DOM and these fiber trees. So what is this fiber trees? Why not simply update the entire DOM whenever the state changes somewhere in the app? So normally using the jQuery and all those things. So what the jQuery, JavaScript and all those things will do is it will simply directly update the DOM whenever the state changes or data changes. Remember how we said that creating the virtual DOM so that the React element tree, so virtual DOM is nothing but the React element tree for the entire app is cheap. So that means for creating, updating the entire the virtual DOM and all those things is cheap and fast because it is just a JavaScript object. So because of the virtual DOM and all those things is JavaScript object, creating of this virtual DOM is very easy and also cheap. Writing to the DOM is not so cheap and fast. So writing the data directly to the DOM is not so cheap and fast. It would extremely inefficient and wasteful to always write the entire virtual DOM to the actual DOM each time that a render was triggered. So this is, so whenever you are trying to write the entire DOM using the virtual DOM means it is extremely inefficient and wasteful. Whenever a render is triggered, so instead of updating the virtual DOM, you go and directly do the actual DOM update means, so this will be very inefficient. So when the state changes somewhere in the app, only a small portion of the DOM needs to be updated and the rest that is already present can be reused. So this is the one step. So you already know about this one. I am moving on to the forward. Now of course on the initial render there is no way around to create the entire DOM from scratch. So but from there on doing so does not make sense anything. So initial render we will update everything in the DOM. So after initial render, whenever a render is triggered, whenever a state is updated in the app, so doing entire DOM update from the scratch is doesn't make any sense. Why? Because most of the DOM will be reused. Only some part of the DOM data only will be changing, modified. So whenever a render is triggered, React will try to be as efficient as possible by reusing as much of the existed DOM tree as possible. How does React actually do this one? So this is the phase. So here this is the place where you need to understand. So whenever a render is triggered, React tries to be as efficient as possible by reusing as much of the DOM tree. So how does this do? Using the reconciliation thing, we'll try to learn it. So that's where a process called reconciliation comes into play. So this is the place where reconciliation comes into play. This is basically deciding exactly which DOM elements need to be inserted, deleted or updated in order to reflect the latest state changes. So this reconciliation is basically, it is the place where it will decide the DOM elements where it need to be inserted, deleted or updated in order to reflect the latest state changes. So a process of reconciliation is gonna be a list of DOM operations that are necessary to update the current DOM with a new state. Now reconciliation is processed by a reconciler. So this process is done by a reconciler. So this process entire thing, so which will do is it's a nothing but a reconciler. and we can say that the reconciler really is the engine of the React. It's like a heart of the React. So this is the reconciler that makes us to never touch the DOM directly and instead simply tell React what the next snapshot of the UI should look like based on the state. So this is the place where the reconciler will do all the things, and it will try to take the snapshot of the UI. So how the UI should look like based on the state. As I mentioned before, the current reconciler is called Fiber. Okay, and this is how it works. So here the reconciler is called as a Fiber. So Fiber means nothing but the React element only. This is the updated version, but I will try to explain you. During the initial render of the application, Fiber takes the entire React element tree. So first, when the initial render is happening, so all the components get executed, and the result then the return and the result of that one will be a component instances, right? So React element, and this all components, everything got executed, it will form a React element tree. In the initial render, we don't have Fiber and everything, so we don't have the thing, and React element tree will be converted into a Fiber tree also. So that means we will be having two types of trees. One is a React element tree, and also another one is a Fiber tree. So entire React elements, so the virtual DOM based on it builds yet another tree which is called as a Fiber tree. So here React element tree is called as a virtual DOM, and based on it builds in another tree that is nothing but a Fiber tree. So here we are having React element tree and also a Fiber tree. React element tree, when I am trying to tell, think that that one is also a virtual DOM. So it will look like this. So initial render, first the virtual DOM React element tree will be created. Here you will be able to see app, you are having navbar model button and overlay H3 button. So here you will be able to see both the HTML elements and also the component elements, everything we are having. And the same thing, the Fiber tree will be created here also. Okay, so here the same thing, Fiber tree will be created. So try to understand that the what I can say is the placement of these all the fibers and React elements, the thing is little bit different. We'll try to explain it. The Fiber tree is a special internal tree where for each component instance and the DOM element in the app. So here each component instance and also a DOM element like H3 button is also placed. This is one called as a Fiber. So there is one. So each one is called as a Fiber. So total comprise of a Fiber tree. So what is the special about this tree is that unlike React element in the virtual DOM, fibers are not recreated on every render. So these fibers are not created on every re-render. So the Fiber tree is never destroyed. So Fiber tree will never be destroyed. Once it is created over the initial render, it will be mutated over and over again in the future reconciliation steps. So it will be mutated over and over in the future reconciliation steps. So here the Fiber tree will never be deleted. So it will be mutated over and over. And this makes Fibers the perfect place for keeping track of the things like current component, state, props, side effects, list of used hooks and more. So the actual state and props of any component instances that we see on the screen are internally stored inside the corresponding Fiber in the Fiber tree. So each component instances like states, props and all those things will be stored in each Fiber also. Each Fiber also contains the queue of work called like updating state, updating refs, running side effects, performing DOM updates and so on. So each Fiber also has these all the things. This is why a Fiber is also defined as a unit of work. So it is also called as an unit of work also, Fiber. Now if you see that the Fibers are arranged in a different way than the elements in the React element tree. So React element tree has something like a parent-child relationship, whereas the React doesn't have Fibers doesn't have a parent-child relationship. Instead of having a parent-child relationship, each first child has a link to its parent, and all other children then have a link to this previous sibling. So like this it will be having. So here if you try to see, so app will be with navbar, model and button, whereas app will be with navbar will go to the model and model to the button. So that means each like a linked list it will be, and model to the overlay will be connected to the H3 will be connected to the button. So it will be connected to the siblings, not the parent-child relationship it will be. So like this it will be. Now where we are, yeah. So it's like a linked list. So this type of structure is called as a linked list and makes it easier for React to process the work that is associated with each Fiber. Now we also see that both trees include not only React elements or components but also regular DOM elements such as H3 and button elements in the example. So we are able to see the H3 and buttons also in the DOM elements, not only the component instances. So both trees really are a complete representation of the entire DOM structure, not just of React components. So here you need to understand that virtual DOM and also the Fiber tree. So both are the complete representation of the entire DOM structure, not just React components. Now going back to the idea of that fibers are units of work, and an extremely important characteristics of the fiber reconciler is that work can be performed asynchronously. So this is one thing you need to understand, that the work is performed asynchronously. Rendering process can be split into chunks, tasks can be prioritized, and work can be paused, reused, or thrown away if not valid anymore. So these all are done asynchronously only. This all happens automatically behind the scenes. It's completely invisible to the developers. There are, however, also some practical uses of this asynchronous rendering also. It enables modern so-called concurrent features like suspense or transitions, which are starting in the React 18. So because of this one, so these are all concurrent features also we can use it. It also allows the rendering process to pause and resume later so that it won't block the browser's JavaScript engine with too long renders, which can be problematic for performance in large applications. Again, this is only possible because the render phase does not produce any visible output to the DOM yet. So this is only possible because the render phase doesn't any produce visible output to the DOM. Now we understood what the fiber reconciler is and how the fiber tree works. But now it's time to talk about what fiber actually does, which is the reconciliation process. So the best way to explain how reconciliation works with a practical example. I will try to explain you with a practical example. So here let's say that the first time in the app you have a state that is nothing but show model is equal to true, and we are having a virtual DOM that is nothing but a React elementary, and app is directly with the model, overlay and h3. So when the show model becomes false means the entire model, overlay, h3 button. So these all the things should be changed, and also the button component also should be, the text content should be updated. So here using this initial render, a fiber tree will be created here. So after creation of the fiber tree, when the state shows show model is false, then this will then trigger a re-render which will create a new virtual DOM. So here the new virtual DOM is created. Why? Because show model is equal to false, right? So the model, overlay, h3 buttons, everything will be removed, and only navbar and button only will be available in the virtual DOM. Now the fiber tree will be like that only. So this is the fiber tree, it will be like this only. So now if you try to see, this is the virtual DOM, and here this is the fiber tree. When this is the fiber tree means app and navbar doesn't have anything to affect when this state has been changed. But this model, overlay which are in red color has been removed, and this button based on the state value, so it is updating some data inside this one. So that means here the DOM elements, these are the only things which are getting updated, fiber tree, fiber elements, and these two are fibers are not getting updated. So now this new virtual DOM will be reconciled with the current fiber tree, which will result in this updated tree, which is called an work in progress tree. So this is the updated fiber tree. Again, this is only possible because the render phase does not produce any visible output to the DOM yet. So render phase doesn't produce any visible DOM. Now we understood what the fiber reconciler is and how the fiber tree works, but now it's time to talk about what fiber actually does, which is the reconciliation thing. So now, so here, so this is the thing. After the fiber tree update, the changes of the list is called as a list of effects. So here when you try to see here this fiber tree, so when the changes are all the things are completed, the effects are completed. So this is called as a list of effects. Okay. So this list of effects is nothing but updated tree only. The result of this render phase contains all the list of DOM updates, and it is sent to the next phase, that is commit phase. So this is also next phase. So here up to now the visible DOM painting, the browser paint has not been happened. So now the creation of this updated DOM has been created. Now it is sent into the commit phase. So that fiber tree. Now this what will happen in the commit phase, which we will discuss in the next video. So this is all about the reconciliation phase, fiber tree and the virtual DOM. So hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.